Hello, everyone. Good evening and welcome to .NET Pittsburgh User Group meetup for this month. You could join our group in the following meetup.com pgh.net, and also we are available on LinkedIn. Please follow us on Twitter, the new X. Today we are going to look into AI for enterprise scenarios and environments. We are delighted to have you all here today, and we are going to discuss on this topic for the next 1 hour. We'll be hearing from our invited expert, Santosh Hari, who will share his knowledge and experience. Santosh has been a public speaker who has been speaking in tech events, and he's a Azure senior Azure Cloud and AI consultant at Microsoft, where he leverages his Azure skill set, mostly focused on the DevOps, and he's also has been an Azure MVP from 2016 to 2020. And Santosh, welcome to the group. And I will pass it over to you.
Thanks, Balaji. Hello, everyone. Thanks for joining this talk. Give me a minute while I get my slides and other things set up. Balaji, thanks for calling me an expert, and that's high praise. I hope to live up to part of that reputation. Let's see. So I'm trying to share my screen, and I'll share screen too. And please do let me know when you can see it.
Yeah, I can see it. Off you.
Great. So with that, I'll go ahead and get started. Hello, everyone. Thanks for joining this talk. I will be talking about Azure AI for enterprise environments. So there's a lot of AI in there, but what I want to stress is if you hear Azure AI or cognitive services, we are pretty much talking about the same thing. These days things are rapidly evolving, so there's a lot of rebranding going on. So bear with me while I interchangeably use those terms. My name is Santosh. I am currently working as a consultant at Microsoft, and I probably have a new role coming up pretty soon, just as teaser out there. But I'll reveal that in a couple of weeks. I used to be an Azure MVP from 2016 to 2020 when I joined Microsoft just as COVID hit. And they also, when you join the company, they make you give up your MVP. So I'm no longer an MVP, which I really miss, being an Azure MVP. That was a lot of fun. I am currently co-organizer of the Orlando.NET user group and Orlando Code Camp. I actually moved from the Orlando area, so my involvement is kind of winding down in that. But by all means, if you have any questions about Orlando.NET user group, Orlando Code Camp, feel free to ping me. I will also say that if you want to reach me, the best place to reach me currently for work related is LinkedIn. I will have the slides on the GitHub repo, so there's no need to take notes. Speaking of which, I'll have the code and slides over the next 2 or 3 days. I'll be updating that, and you'll see the latest version of the code and slides. Feel free to scan that QR code, and it'll take you directly to my GitHub page, and you can also use that URL shortener. Before I jump into it, I want to start with this quote, which I've been using quite a bit these days. AI won't steal your job, but those learning to use AI will. So that is why I go about giving these talks on AI. Is not because I feel like AI will steal your jobs. I just want the audience to be armed with better knowledge of the evolving scenario. Speaking of which, my agenda for today. So, as a consultant, I get to go into a lot of customer environments, and I also have teams that I take into these environments. So what I see is, especially with AI, but also with other technologies. So this is a pretty universal problem. People start with quick starts, and then you're thrown into enterprise environments. So uh, I, I want to kind of follow this agenda to talk about what a quick start looks like. How do we build on the quick start to better suit it, a code for enterprise? And since we're talking about Azure AI, I want to talk about how to run that in containers, which is what is mostly, uh, which is quite a significant portion of enterprises are starting to use uh, containers for Azure AI. So I want to talk about that. I want to talk a little bit about container ops issues, some of the other gnarly issues which you may come across, and then we'll uh, end with a architecture diagram. I don't want to you know hit you with the final architecture, but maybe I'll do that at the beginning. We'll wait and see. So Azure AI Services, also known as Azure Cognitive Services, these are a set of services that help developers and organizations rapidly create AI applications. And by the way, if there are any questions, feel free to put it in chat, and I am more than happy to answer those questions. Coming back to this, these are out of the box and pre-built and customizable APIs and models. Examples include, natural language processing, document processing, monitoring, translation, speech, vision. There's a whole bunch of Azure AI services. And of course, these days you also have OpenAI slash ChatGPT, which is part of Azure AI. But I will not be talking about ChatGPT. So sorry for the disappointment. Azure AI services are mostly available through REST APIs. So any SDKs that you see in these uh, in this talk is just a it's a abstraction layer to talk to the Azure AI REST APIs. And some of the development options for Azure AI include, you can use integration tools like Logic Apps and Power Automate. You can use deployment options like Azure Functions and App Services. You can use containers, which is what we'll be talking about today. But you can also use Azure AI with tools like Apache Spark, Databricks, Synapse, and so on. And of course, AKS, Azure Kubernetes Service. So since I was talking about quick starts, let's get started with one. So this is the most simple quick start instance that I can think about. In this quick start instance, you have a Azure AI or Azure Cognitive Service instance that gets spun up. The person spinning up gets the endpoint and the key. They put that into the application and they run it, and it connects and performs some work. So with that, what I want to do is I'll dive into some uh, quick code that actually does this. So okay, so here is a Azure Cognitive Service. So I'm calling it Cognitive Service Pit, just so I can recognize which instance I'm using. And okay, so this is Cognitive Services Pit, and what I do is you can create this simply by going to the portal, creating a cognitive service and providing some input parameters. One is not different. One instance is not different than the other, so I will not bore you with that. The main thing I want to show in here is the cognitive service. Once you provision it, you'll have to come in here to get the key and the endpoint for your app to work. And what does your app look like for cognitive service? I will start. I have multiple applications, so I'll start with the first one. In the first one, I will be using the endpoint and the key. And what I'll do is I'll scan this particular image. So this image. Let me see. Let me close this one. Reopen it. You will see that this image has some text in it, and I'm trying to get this to scan the text in the image. So a pretty straightforward operation. So I have my code right here. So let me close the image. And I will open up the actual program file and walk you through the code. And since this is pretty straightforward C# code, like I said, most of the Azure Cognitive Services SDK, it's simply a wrapper to get to the REST API. So I'll try to treat this accordingly. So to run this, besides the usual libraries, I'm adding an extension configuration. So .NET add from the console, you add this package to read a configuration file. And then I import I add a couple of other libraries, Cognitive Services Vision library, and I use these two namespaces for those. And then I'm using the Azure, I don't think I need the identity in this particular one. Wait, I was in the wrong one. Sorry. The endpoint API is pretty straightforward. So all I need is the Vision API. And then you'll see that I have app settings.json in which I'm using some horrible practices, which is encoding the endpoint and the service key. So this is where most of our quick starts like to leave us and then tell us to figure it out on our own. So let's kind of get this working. So what I want to do is I will get the key from here, the updated key from here, and paste it. And then I want to get the updated endpoint name here. So let's look at the code. We talked about the namespaces. So this is a simple console program. It's using a computer vision client, which it's calls from the SDK. And then it uses the iConfiguration to load the Cognitive Services endpoint and the Cognitive Services key values. It creates a credentials object using the key, and it instantiates the client using the credentials object and the endpoint. So pretty straightforward. So this is the client that we'll be using to process the image. And I have three options in here. The option one reads the lincoln.jpg, which is the file I just showed. Option two processes a PDF, and option three reads a note on a JPEG. So when we run this, let's go with option one and kind of, just to prove the point that Cognitive Services works, we'll just use option one. So what happens is when this program runs, it based on the option, it passes the image file name. So it creates a stream of the data in the file. It connects using the Cognitive Vision client, and then it sends the image data to the client. And when it's done, it comes back with a set of results. And if after it's completed, what we'll do is when we get our operation code succeeded, we will read some values, and supposedly it claims that it can read the text, and the results contain the text, but they also contain something called a bounding box, which we'll see what it is. So What I'm going to do is in the console, so let me make sure I'm at the right console. So open it integrated, make sure I switch to the proper one. Any questions while I'm waiting on this? Okay, cool. So please comment on the cost of a. Okay, so good question. So Azure AI services, they have two cost models. You have a pay-as-you-go, which is the most common one, which we use in PaaS, but can do a consumption-based, not consumption-based, but you can kind of do a commitment-based um, pricing model. So you can sign up for a commitment-based signing model saying that I will spend X amount of dollars on cognitive services. So what the commitment model does is it kind of helps you plan out your uh, monthly spending slash quarterly spending, whatever budget it is for large enterprises. So large enterprises often tend to do commitment based because you get a cheaper price compared to the pay as you go model. So hopefully that answers that particular question. So I'll move on to this one, and we'll do a .NET run. And when I do the .NET run, it goes in. It should ask me for my options, saying do I want to read image 1 or 2 or 3. So let's see. Oh, there you go. So it's asking me if I want to read API. So I'll read the Lincoln image, which is option 1, and hit enter. So there you go. So it's reading the Lincoln image. So it comes back and it says, in this temple, as in the hearts of the people. So you can see that it went through and looked at the text in the file, and it was able to process that, and it completely ignored the statue. And it also gives a bounding box, which is kind of the coordinates. So think of the bounding box as angle or a polygon on a map. So it's basically giving you the area, the actual photo in which the text, each line of text was contained. So you'll see that the first line was contained in this bounding box. The second line was contained in this bounding box. So you'll see that it's starting to move in a certain fashion. So that's what the bounding box is. So we can often use this to, you'll see that people may write code that goes in and removes text from images. So you could hypothetically do that, if you had bounding box and additional code to replace the content of the bounding box with a different content. So that's one example of Azure Cognitive Services. Now, I want to not simply dwell on that. That was a pretty simple example, but also want to point out that this is a pretty straightforward one, right? Like you're saying that this is the equivalent of putting your key under your front door mat and telling your friend that, hey, when you come to my house, the key is under the front door mat. Yeah, sure, your door is locked, so if someone comes and tries the door, it won't work. But if they know where to find the key, they can simply go in and start hammering your cognitive services account. So you're basically handing over the key, telling anyone on the web to use this. And certainly, it doesn't work in any enterprise situation. In fact, if you go into enterprise and this is kind of like a smell test, right? So if you see a cognitive services in app settings.json, that's there's some work to be done over there. The reason being that even if they're not worried about data exposure, someone could easily run up a crazy bill. So I want to kind of start evolving this code. So what we'll do is in the next one, we will use something called Azure Key Vault. So the way I would describe this is, I recently underwent this, the American time-tested tradition of becoming a homeowner. A real estate agent takes you from home to home. They don't have the keys to each house. They have a lockbox. So you go to the house, you punch in a code in the lockbox, you get the key, and you open the door. And when you're done, you put it back in. So that's kind of an added level of security instead of simply putting it under the mat. So a key vault works in a similar fashion. So instead of distributing the key freely, you pick it up from a key vault, and you have a secret code to the key vault. So that's what this diagram is showing. You can see that in as soon as the cognitive services is provision, the first thing someone does is they get the endpoint of the cognitive services, and then they also go in and store the key for the cognitive services in the key vault, which is item number 2 in this diagram. And then from there, Azure AD gives something called a service principal, and the service principal is it gives you have two things you need from there. You need the permissions that it provides, and you need a secret. So using the secret and the permission, you can retrieve the key, and then you send the endpoint and the key to the cognitive services to process some code. Hopefully, that's clear enough on what it does. And I don't see any questions, so I'll keep going. Balaji, are there any questions, or do you want me to keep going?
Nothing at the moment.
Nothing at the moment. All right, cool. So a couple of things I want to point out. I have a key vault in here. So this I just created. So this key vault, you'll see a couple of things in here. So as I go in and look, it says I'm not authorized to view these contents, but that doesn't mean I cannot store. Yes, please feel free to ask your questions in the chat. So first thing I'll do is I'm going to go to my Azure Cognitive Service. I'm going to grab the key, and I'm going to put it in my lockbox, aka the key vault. So put it in the secrets. And let's see, I have a name for this. So I'm going to call it the cognitive services key, as it's mentioned in my code. And then for the secret, what I'm going to do is I will grab the key and put it as the secret. So ideally, this should not be done manually. What usually happens is when a DevOps pipeline runs, that's provisioning the key vault and the cognitive services, that the pipeline itself grabs the key and it inserts it into the key vault. So that should be an automated process that humans should not be involved in at all. So creating this service. Let's see. It's not allowed by RBAC. Wonderful. Okay. So, as you can see, it's already super tight on security. So I'm going to go in here and see if I can. All right, so I will not belabor this point because I have a lot of material to run through, but I'll simply walk through my code. As usual, the demo bugaboos got me, so bear with me while I do this. So again, this is the same program, right? So this is not any different. But what I'm doing is when I actually um, uh, instead of storing the key for the cognitive services, I'm only storing the endpoint. But instead, what I'm doing is I'm storing the name of the key vault, and I'm storing a few uh, variables that tell me what the key vault does. So, this is something that you can get. So maybe I can run a command to get this. So what I have is, what I'm trying to do is I have a, sorry. So in order to access the key vault, I went to Azure Active Directory and I provisioned uh, a application, enterprise application, also known as service principal, that has access to the key vault. So if you go in here and if you search for SVP, yeah. So basically took a service principal, and then I saying that this service principal has access to the key vault. So that is what my code is doing in here. It's saying that this is your key vault, this is your service principal details. So it needs the tenant ID, the app ID, and this app password. This app password is the secret code. So if the key vault is the lockbox, this is your code that will unlock the lockbox. So uh, so then, I go to my program, and this is the same program, right? This is not any different than the previous one, but you'll see that I added a couple of additional items in here, and these are Azure Identity and the Key Vault Secrets. Uh, so it's the same program. It has the computer vision client, but you'll see I have a few additional lines of code. So what I'm doing is I'm also getting the name of the key vault, the tenant ID, the application ID, and the app password or the secret code. And then I connect to the key vault using a client secret credential, which uses the tenant ID, app ID, and the password. So when I connect to this, I can instantiate a key vault client, and that allows me to get the cognitive services key, which is actually the value that's stored in the key vault. So at this point, it becomes the same as the previous code in which I was trying to get the cognitive services key directly from the cognitive services. So this kind of puts in an additional layer of complexity. And the rest of the program is the same. So, when you run it, it'll go in and it will ask for uh, the image you want to read, and once you read the image, it comes in here, and it actually processes the same image and provides the same output. So there's a couple of what we saw was you can kind of go with a quick start, but a quick start is and puts in some really bad practices, and you can kind of start to build on top of that. You start using a key vault to store your secret instead of just getting it and storing it in plain text. So that's definitely one of the ways to do that. So in the but you take this and then you kind of go to an enterprise environment, and this is what it looks like. This is the problem I see is we teach our developer teams with quick starts and then throw them in enterprise environment that looks like this without guiding them through how this app will even fit in there. So this is an example of an Azure landing zone. As you can see, there are at least like 7 or 8 blocks, if not more. You have like an enterprise enrollment block. You have management services, uh, DevOps block. You have connectivity, sandbox, identity, and so on. And the AI services that are deployed in the subscription are in the little red box at the bottom. So you have to make sure that when you start building, how does it start fitting in? So that's what I'm going to talk a little bit about today and show how containers fit into this whole process. So this is by no means a thorough walkthrough, but I at least hope to implant some ideas in the audience's mind, saying that okay, so this are some of the things we can look at. So let's build on the quick start. So we saw, where you can take your keys, and I'll pull up the keys so we can kind of talk through it. So these are your keys for the cognitive services, and you have 2 keys, not 1 key, right? And there's a reason they provide 2 keys, because they want you to use something called a key rotation. So in the key rotation, what you do is you basically take the key 1 or key 2 and start using that in prod. So let's say you use key 1, and in the next step, you decide at a previously decided interval you want to rotate the keys. So you modify your app to switch to key 2. So that can be done in a variety of ways. You can even have something in the background that tries to see if key 1 is active, and if it's I want to switch to key 2, you can run it, and you just do a deployment, time deployment, however it is, right? You can use a feature flag to do this if you so choose to. So you switch to key 2, and then you can do a process called rotate. So you can see that you can regenerate key 1 or key 2. So the moment I switch to key 2, I hit the regenerate on key 1, and that will actually generate a brand new key. So at that point, it's fine. My key 1 can sit in there, and it can just continue sitting in there. After a while, I repeat the process, but instead of key 2, I switch to key 1, and then I rotate or I regenerate key 2. And I keep doing this in a repeatable process. So the best option to do is to automate this. So this kind of protects the privacy of your resource. If a key gets leaked, if you're rotating it at regular intervals, a key gets leaked, it rotates out ultimately. But that's another additional level of complexity you can add on top of using a key vault. The next thing you should probably be doing is in your C# code using environment variables. So as you can see in the bottom, this PowerShell script that sets the environment variable with the value and a user. So if you're using keys in a development type environment, instead of storing it in app.json, maybe you should be reading it from an environment variable as shown in here. So the story also, one of the things we saw is that the application that was running the service principal was actually storing the service principal secret in the app settings.json. It should probably be stored in the environment variable. So this is where we can start getting into real enterprise-y type stuff. So in the previous scenario, you came over the open internet and you simply you're able to access the key vault, you're able to access Azure Cognitive Services or Azure AI and so on. So in real life, when we go to customer sites, this is if you start accessing any kind of Azure resource over the open internet, that'll kind of draw a red flag. So that customer IT teams are usually pretty savvy, and this it'll not be allowed. So your app will start to look something like this. In this scenario, everything is completely within a private network in Azure. And when you put in private network in Azure, what happens is, for instance, you take an app service, right? So you're putting it in a private network. Nothing can talk to it except other resources within the same network or peer networks. They can talk to your resources using a service called private endpoint. That's the one in yellow that's sitting at the center of the page. So all the traffic goes through private endpoints. And so, if you have your app service talking to your cognitive AI service, it goes through this private endpoint. Uh, so just otherwise, if you don't use a private endpoint, your service is not accessible within the private network. And end users they can access your application using a Bastion service or some kind of DMZ based service. So this is where it starts to get complicated. But this is also starting to represent a true enterprise environment. Um, so Now, building on the previous example, this is the equivalent of going into a house with a lockbox. So the lockbox is the key vault. You're going into the house, which is the cognitive services. But first, you have to get into the community through the gates. So this is where it starts to really lock down your security and become more "quote unquote" enterprisey. And I'm constantly checking for questions, but feel free to drop any in the chat. So the next one, and this, when you get to this point, is when I start to feel comfortable. So in this scenario, it's similar to the previous one. Everything is completely within a private network. Communication between resources happens through this private endpoint service. So this is your private endpoint, and all the kind of communication is happening through this. But you will see that in the previous example, I had like 5 or 6. I had like 6 steps to get through to actually make the call happen. In this one, it's much shorter. So there's only 5 steps. So the way it works is you still have to do the, store the key in the Azure Key Vault, but instead of going through to Active Directory using a service principal and a secret to access the key vault, what you're doing is you're enabling something called a managed identity. So in this one, you are saying that this particular application is getting its own identity, and this identity has permissions to access this key vault. So this application accesses the key vault, gets the key, and makes the call. So it's makes it much more efficient. Also, the added advantage of this is you can authorize individual applications, or you can. There's another way to do this called user managed identity, but we'll not get into that right now. But you're authorizing a application to talk to a resource directly without using any secret code. So there's no need to store a secret code. You just it's kind of you are giving this a additional special power to say that you can you application or you resource have the permission to get a key from the key vaults, and that makes your code far more efficient because you're not like having an additional secret that you need to pass. So building on the previous example, you first have to get into the gated community, which is a private network, and then instead of using the secret code to open the lockbox, you're using something of the equivalent of like NFC to unlock the lockbox, or Bluetooth to unlock the lockbox. So just it's far more efficient, and it's more proximity based, for lack of a better term. Questions before I dive into cognitive services? Right. cool. So now I want to discuss cognitive services deployed with containers. And since we're speaking of private networks, you can deploy cognitive services not just in Azure private networks, but you can also deploy them on-prem, which makes them really, really attractive to enterprise customers. Because if you go into a lot of enterprise type scenarios, you have not only like the private networks locked down, but you'll see that a decent chunk of resources are still on-prem, and this is for good reason. Like there are various compliance requirements that enterprise customers are go through, and some of them actually require you to have like a physical tightly control the physical location of your data. So just giving some examples, like a doctor's office, or even more complicated, I guess, like social security administration or anyone else. They might not want to let the data leave their premises where the data center is. So that's you do run into these quite often in the enterprise environments, and containers are a great way of overcoming that. You also have IoT type scenarios where you have you require some kind of intelligence for your IoT applications. So this is used in edge computing type scenarios. You can take the same APIs and you can make them available on-prem, on the edge, and in private networks. Using these containers kind of gives you the flexibility to bring Azure AI services closer to your data. And this helps with compliance, security, and other operational requirements. And keep in mind that container support is only available for a subset of the Azure AI services. It's not available for all of them. So let me dive into creating a container. So this is I want to create a container instance. Uh, and what I'm trying to do is I'm trying to pull down a cognitive services container and host that container image somewhere so that I can pull it down from my application. So just with that in mind, I'm creating one. It's the same resource group. I'm giving it a name. Uh, we'll just go through this, but this is where it starts to get interesting. So instead of using a quick start image or container Azure Container Registry, what I'm doing is I'm actually going to the Microsoft uh, Container Registry. So let me see if I can find the name of the Microsoft Container Registry. So I want a Microsoft Container Registry, and you can find them over here. All the Docker containers are available in the Microsoft Container Registry, and you'll see that I have this link in my slides, so I'll share these with you. But you can pull a whole bunch of, or a subset of Azure AI images for speech, language, decision making, vision. So vision is the one we'll be using, and document processing. So I'll use the one for vision, and the one for vision uses this. So that is the name of the image. I think that's the one. And it's a Linux image. We'll just go with whatever they're mentioning. Currently, I will just keep this public, but keep in mind that I don't, ultimately, I would like for it to be private, like we mentioned in the previous slides. One thing you have to do when provisioning these images is you have to add a few parameters, and these parameters they look something like this. So I'll need to add the EULA, and the EULA is basically the license agreement, and what I'm saying in here is I accept the license agreement. The next one is the billing. So the billing was basically the endpoint of the Azure Cognitive Service. Having done that, I'll mark it secure. And finally, I have to add the API key, which is the key for the cognitive service. So I have to use these when I'm provisioning the container instance. If you're using Docker, then it would be a command like Docker run, and then you provide these three values as parameters, and that will take care of that. So let's try to run with this and see if we can get a Docker image up and running. And while that runs, what I'm going to do, yes, please. I'm giving a lot of information, so you should probably be asking questions. Okay, so this container takes a while it's running. I'll get back to this shortly. What I want to do is save some time and start talking about some of the items related to container ops, quote unquote container ops. So one of the things you'll have to deal after you have the container, let's say you're doing it in a private network, wherever it is, right? So the container is unless you get specific permission from Microsoft, and we'll talk about that, the Azure AI containers will require connection, at least periodic connection to the internet, because they need to connect to the billing service. And if you're deploying this in private networks or on-prem, make sure that whichever proxy you're provisioning has outgoing access on 443 to these domains. Otherwise, your containers will stop working. They will not return any results. So basically, this is like a allow list that you need to configure. Updates and versioning. So you need to keep track of the latest versions of the containers that you pull either in private networks or on-prem, and update them regularly. You need to also test your application compatibility with newer versions before deploying them in production. And containers, these containers use the standard Docker tags, so you can use the latest tag to pull the latest. One thing I'll say is Microsoft always recommends that customers switch to latest versions of the containers as they're released, not just because it's the latest and the greatest, but also there are plenty of bug fixes and security holes that get fixed each time. Also, one of the other reasons you probably need to switch to the latest version of the container is because if you're talking to support, they will not answer questions if it's an older version. Only if it's the latest will they answer, provide support to that. A couple of other things. Have major versions, that's a breaking change. So if there's a change in major version, it's almost certainly a breaking change in the API signature. If it's a minor version, it's most likely a bug fix, a update to the underlying AI model, or it's a new feature that doesn't change the API signature. That I'll go back and see if I have my container instance. Okay, so I have my container instance running. I forgot to provision FQDN. Never mind. So I have my container instance running, and this container instance is running a version of the Cognitive Services Vision container. So I'm going to see if I can actually, call this, this container and get what I can get out of this, right? So I'm going to go to this. Since I forgot to provision a FQDN, I'm going to pull up this container. And remember that I used port 5000 instead of 80. So let's see if it pulls up. Okay, so the container is up and running. you can click on the service description and it will actually get you to a Swagger endpoint, which actually gives you a whole bunch of useful information. And we'll talk about this shortly. But I want to show you a cool example of what you can do with this container. So let me leave this here. I'm going to go to, and I'm going to pull up something called Postman. You don't have to use Postman. You can use any type of client. And one thing I'm going to do in here is put in my IP address to access the container. So this Postman has a collection that has two requests. The first request uses the IP address and the port number, and it's supposed to connect to the container. And I'll make sure I'm using the right. So v3.2. So it actually connects to my container, and you will a couple of other things. You'll see that I'm going to go to the body and let's start with the header. So this is the header, nothing great in here. And then when I switch to the body, you'll see that I'm actually passing a image to this service. So it's supposed to process this service and return some kind of results. So let me switch over to this. Let's pull up the image, make sure it's a valid image. Okay, so I'm doing a demotivational posting just for fun. So when I send this, it should actually give send this particular image to my container, right? And the container should process it. Let's see if we can get a result back. If I provision this correctly, it should work. The one thing to mention is that I'm sending it to the container, but I did not really could not send request. Okay. I apologize for this. I don't know why I'm having horrific issues with my demo today. All right, so what this does is it actually sends the image to the container, and it's supposed to process and return it. I'll see if it's because I did not, maybe I provisioned something. It allows from all networks. Probably did not provision enough memory. Let's see if this works. Okay, so I'm going to see if I can auto scale this and make it work. So response could not send request. Okay, let's just use the container itself directly. So what I'm going to do in here is I will use the Swagger API. So in the Swagger API, you have a try it out. And in here, let's see if I post the image contents, if it will get me a result. Okay, so what it did is it's the equivalent of sending a curl request. It went in, it sent my image, and then it gave me a response. But you'll see that in the response, It did not give anything regarding the image. That's because you have to send two back-to-back responses, and that's what I was trying to do with this uh, particular Postman request is. I send a first request, it gets a response. The response basically contains something called operation location, which is a URL, which actually is where you can go to get the results. And I think this helps with things like large requests, where you send the request and then you can keep checking back to see if you have a response of the URL. It also helps with things like pagination and so on. So let me copy this URL. I think something is broken with my local instance, which is why I'm having these issues. Oh, there you go. Maybe, hold on. I can probably get this working. It's probably sending it the wrong value. Either way, while we wait on this, I'm gonna grab the URL that I got from Swagger and see if that works. Never mind. Something is broken with my Okay, so let's grab this. So this is where I can go to get the results of my request. And when I send this, it goes out and you'll see that it actually had a 200 successful. So I can go in and read the results, and it's giving me the same thing, bounding box followed by text within that bounding box. So you'll see that it basically passes a bunch of text with bounding boxes. So that is actually my container in operation. So I don't know why my Postman instance didn't work. Another thing to fix. But again, I have all of this code and on my GitHub page. I will make sure that I fix whatever it is, and you can actually use this Postman service to actually go in and make requests against it. Ooh, okay. All right. So, any questions so far? If not, I'll keep continuing. Yeah. I think I'm coming close to time, so we'll try to
At
rush.
the moment,
At the moment, there is no question. Okay. So there is another container you can pull called diagnostics container. So it's a simple Docker pull and run, and you'll see that it's the same, follows the same pattern. You can run any Azure Cognitive Services container using this pattern. So you have to pass the EULA, the endpoint URI, and the key. And you can pull down any Azure Cognitive Services container that's currently available and run it. And this diagnostics container, actually, I recommend using this in like any kind of instances where you use Cognitive Services container, because it helps you with debugging common errors, like if you did not open a port properly, or if you did not configure the API properly, it gives you the result on exactly what's going on with the environment. So other ways to look to debug issues is to view logs from your application code within a container. You have a command called az container logs, which will actually help you do that. Similarly, az container attach command, it actually provides diagnostic information during a container startup. So that's the attach output streams in this one. And if your container fails to deploy successfully, you can review the diagnostic information, and you can use az container show command. So all of this is just like running containers. Like as long as you have a container deployed in ACI or container registry or container instances or AKS, you can you have a lot of options to debug them. So you also saw in this previous instance where I had the Swagger API, it had a few other endpoints, namely health check, readiness check, disconnected usage. So these are basically um, so these are some of the options that are available. So the ready and status, these are the Kubernetes liveliness and readiness probes. This you can use these two endpoints for that. And then the Swagger is kind of the documentation page, and the localhost gives you the home page. The first command, ready, it provides you verification that container is ready to accept requests, and the second one is verifying that the API key used to start the container has actually worked properly. These are some common status messages. If you're getting anything but a valid, you have some issues. Some other things to know, and again, I'm going to put these slides, so no need to memorize this, but you have a container running in. You can run containers in disconnected mode. So this gives you a matrix of some of this. And when I say gated actually means that you to run some of these in disconnected mode, you have to get approval from Microsoft, and they'll give you a special license key to put in the container. Speaking of disconnected mode, it's often used for on-prem or IoT type environments. You have to request special access from Microsoft. The product, you basically, they give you a license key instead of the API key to run the container. So you get a slightly different methodology to run this. The billing proxy, you have to, even though it's running in disconnected, you occasionally have to sync with Azure to upload your billing data. And then you can only do it for a limited amount of time, like 90 days. And when you run it in disconnected mode, there is no SLA. And these are the set of services that allow you to run in disconnected mode. And finally, comparing some scenarios. These are some of the advantage, pros and cons. So, for instance, with PaaS, you require internet connection 100% of the time. But with other instances, you need intermittent internet connection so they can upload billing data. Ease of access, PaaS is easier to access as compared to other environments. But PaaS will always fail compliance. So if you are doing 100% open public over the public internet, you will never meet any compliance standard. But infrastructure management has, if you're using the public version, you have all the advantages of PaaS, but you have the disadvantage that it will fail compliance. And if you're using AKS within a private network, you have to handle that orchestration complexity yourself. So one thing to keep in mind when you're running on-prem disconnected mode, it's a commitment only type billing. It's not consumption. You cannot do pay as you go. And coming back to this thing, when you go and deploy these, you usually deploy them in landing zones. The landing zone approach helps you manage your resources in a structured, consistent manner. But usually, you're deploying in this small box right here. This is what it looks like blown up. So, you deploy a cognitive services, and you can see that it starts to refer back to some of those previous slides we discussed, where you're using a private endpoint to do connections between them, and you're using like network security groups, managed identities. So, again, I want to kind of end this by. I hope that this was interesting and informative. I would like to do an extended talk on this one. Maybe I will just hit me up if you'd like to hear an extended talk on this one. I can fix. I need to better fix some the middle code that did not work, but that's part of life. We'll get that figured out. I'd like to end this with a call to action. We all start with learning apps with quick starts. There's nothing wrong with that. But I encourage you to think beyond the quick starts and start building your applications with a bigger picture in mind. With a little bit of thought and foresight, you can actually build successful AI applications that can run in any enterprise environment. These are some of the resources, and you can get the code and slides in a couple of days at this particular location. And with that, I will stop sharing. And yeah, well, let me know. Then I didn't see any further questions, but always open for discussions. If I'm wrong, code sucks, feel free to just provide feedback. Hit me up here. Hit me up on LinkedIn. If you need the code samples, happy to provide those.
Yeah, thank you. That was really good. Appreciate you taking time, and I don't see any questions at the moment. And if there is not much questions, then thank you everyone for joining us today. And thank you, Santosh, for taking time and walking through this, the new AI stuff. You prove yourself. Thank you.
Thank you, everyone. Have a good day.
Thanks.
Bye.